Okay, good morning, afternoon, or evening, everybody. Welcome to the Gridded Population and Settlement Data, an introduction to the POPGRID Data Collaborative webinar. This is your host, Jennifer Brennan. I've got 2 p.m. Eastern Time, so we're going to go ahead and get started. And what I'd like to do first is go over a few webinar logistics. To ensure the best audio experience, participants have been placed in silent mode, but if you have any questions or you're having any issues, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located on the lower right-hand side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted to our online Adobe Connect webinar catalog, as well as to our NASA Earth Data YouTube channel within a couple of days of completion. Once completed, I will send an email to all registrants with recording links. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstrations, and an additional 15 minutes for the question and answer period. During today's webinar, we do have 2 speakers, Dr. Alex Desherbinen, who is the Deputy Manager for NASA's Socioeconomic Data and Application Center, or CDAC, and also the Associate Director for Science Applications at the Center for International Earth Science Information Network, or CESIN. Our second speaker is Kit McManus. He is a GIS developer and Senior Systems Analyst at CESIN. Once our speakers for today have finished with their presentations and the live demonstration, we will transition to a final optional set of polling questions. And generally, I'll give these questions about 3 to 4 minutes or so, and then from there we'll move directly into the Q&A period. Depending upon the volume of questions that we receive today, we'll extend the Q&A period an additional 15 minutes from end time for those of you who wish to stay on the line, but we will have a hard cutoff at 3:15 p.m. Eastern Time. All right, at this point, what we'll do is we'll pull up today's agenda. Give this just a second or so. Today we will begin the webinar with Dr. Alex Desherbinen. He'll provide a brief introduction to NASA's CDAC and also an overview of the POPGRID Data Collaborative. From there, our second speaker, Kit McManus, will discuss an overview of gridding approaches and also introduce both the gridded population and settlement layer datasets. We will wrap up today's presentation with a live demonstration of the CDAC POPGRID viewer. This is a tool that really helps users evaluate the data products side by side and also characterize any uncertainties in the population estimates for different areas. With that, it is my pleasure to introduce today's first speaker, Dr. Alex Desherbinen. Alex?
Oh, thank you so much, Jennifer, and thank you to all of you for joining. I'm going to be sharing our screen here, so hopefully that will go smoothly. Can you just confirm, Jennifer, that you're seeing our screen?
Yes, I do. Thank you.
Okay, thank you. So without any further ado, I'll go ahead and jump in, since I know some of you have been waiting a little bit to have this start. So I'll be providing, as Jennifer mentioned, a little overview on CESIN and CDAC, talk about POPGRID. Kit will give an introduction to gridding population and what goes into that. I'll be describing some use cases and some gridded population products, and Kit will close things out by talking about settlement data products and giving us a demonstration of CDAC's gridded population grid viewer. So just by way of introduction, CESIN is a center of the Earth Institute. We're based outside of New York City at the Palisades Lamont campus of Columbia University. Our focus is on applying information technology to pressing interdisciplinary data, information, and research problems related to human interactions in the environment. We have roughly 40 staff, interdisciplinary, with a very strong emphasis on geospatial. CESIN runs or manages for NASA the NASA Socioeconomic Data and Application Center, which is one of 12 distributed active archive centers under the ESDIS project, the Earth System Data and Information System project. CDAC data provide the ground level context for NASA's remote sensing data. We focus on human dimensions of environmental change with a big focus on data integration, and you'll see why we focus on data integration through this presentation. We support scientists and applied users and decision makers, and we have very strong links to the geospatial community. So let's step back a second, sort of try to frame why we're having this conversation, why we want to present on the different population grids and some of the methodologies that go into them. And this is a quote from a recent paper that actually Kit will be describing in a bit more detail in a moment, by Stefan Lake and a number of us, including Kit and myself as co-authors. In this quote says that the distribution and density of human population continues to be a critical component to measuring, mapping, and understanding human environment interrelationships, identifying populations at risk of infectious diseases or disasters, and informing management and policy decisions from local to global level initiatives. And there are quite a number of use cases. I'll be providing just a handful later on in this presentation, but you can think of population grids as being critical for planning purposes, for transportation management, for disaster risk mitigation, for climate change assessments, for public health campaigns and assessments, and sustainable resource management. So across a whole range of issue areas, population and settlement data are critical. If you take the perspective of the Sustainable Development Goals, this is a graphic developed by the Group on Earth Observations, and all the dark rectangles basically show, or darker blue rectangles show, where remote sensing can be applied to some of the issues under each of the 17 Sustainable Development Goals. But what you'll notice is that population distribution and cities and infrastructure mapping are critical to all 17 of the Sustainable Development Goals. So POPGRID was developed in 2016. Actually, it was a brainchild of Bob Chen, who's our director at Season. It's a data collaborative for settlement, infrastructure, and population data. Essentially represents a public-private partnership with intergovernmental organizations, national academic research institutions, large and small companies, NGOs, foundations, et cetera. In the last year, we've actually added the Global Partnership on Sustainable Development Data and the Sustainable Development Solutions Network as sort of part of the management team in addition to Season. We've received funding from the Bill and Melinda Gates Foundation. But the impetus for the work really began with the developers listed on the left-hand side, many of whose products we'll be describing in more detail today. That includes WorldPop, which is a collaboration among several partners, including the University of Southampton and University of Louisville, the German Space Agency DLR, JRC, European Commission in ISPRA, Italy, Facebook and Internet.org, Esri, Oak Ridge, and many others are involved in developing new products, and there was a sense that this community needed to come together and better understand user needs and also better assess the quality and validity of the data products that they're producing. So that's, in a nutshell, what POPGRID is about. We do have actually a wide and growing number of user groups that are actively engaged with us, from Google Earth Engine and the World Bank and UN agencies to UN, the International Federation for Red Cross and Red Crescent. All of these groups are very actively engaged with us, and we have others that we've been working with more recently. So in a nutshell, POPGRID is needed because of the proliferation of data, both on the population grid side and the settlement layer side. These new data using different input data and different methods, which are developed for different purposes, can confuse the user, and the user can be left wondering what product they should use. So we also, if you begin to do analyses using the different population grids, you begin to realize that, in fact, the numbers you obtain from any given analysis can vary substantially from one gridded population data set to the other, even if you're using exactly the same methodology. We'll be saying a bit more about the website in some of our subsequent slides, but the URL for the existing website plus an improved beta website, which will be released very shortly, we hope by the end of this week, are listed at the bottom of this slide, and users are encouraged to visit those sites because they provide additional details on all the partners involved and all the data products that each of those partners develops. But to transition now, I'm going to pass the mic to Kit McManus, my colleague, who will be describing a bit more what goes into gridding population.
Thanks very much, Alex. So as Alex introduced nicely, there has been this proliferation of population and settlement data over the past decade or so, but it kind of begs the question, why do we want to grid population data at all? As many of you are very likely familiar with, population estimates, they usually originate in a census enumeration or some other type of survey, like a demographic health survey, for instance. And they usually report a single number for some given polygon. So those polygons, they could represent things like provinces or counties or municipalities, or, in the best cases, we're able to obtain information that represents enumeration areas that were used directly by census bureaus. But, having this single number for a large polygon can be problematic when you want to do analysis on different units. For instance, we show here Lake Chad Basin catchments. So, if we wanted to add up the amount of population in each one of those catchments, it's not possible to do that using polygon data. So we grid the population data in order primarily to allow for that type of reaggregation into other types of geographies. But also, in a gridded format, population data integrates better with remote sensing information that is normally raster type data, represented at a pixel scale. Rather than having a wide array of different polygon sizes and shapes, when we grid population data, we normalize the unit to a pixel that is the same shape and size throughout the entire study area. And it allows us to integrate data across many unique geographies into a seamless global grid. That's why we grid population data. Now, why would someone want to produce settlement extents? So a little bit tongue-in-cheek, it's a key input for population grids, of course. And, that's what we care the most about. But, in all seriousness, settlement extents and settlement data on its own is very valuable. If we have information about some administrative area, it's very useful for us to know which parts of that administrative area contain built-up settlements versus open water or, bare impervious surfaces or any of the other types of land cover that could be within an area. A nice thing about producing settlement extents, whereas population data normally originates in a survey or a census, settlement information can be obtained looking exclusively at remote sensing data. So that's something that can be reproducible over time. There's also a large store of historic data from the Landsat program that could be potentially incorporated, so we could look at, changes in settlements over time. And, also going into the future, this change analysis is really closely linked to remote sensing data, which, is obtained much more frequently than census enumerations or any other types of surveys. Alex also introduced this seminal paper that, was recently published in 2019. The lead author on that is Stefan Lake from the University of Colorado, but many of the co-authors, myself included, are from groups that have been primary producers of global and regional population data. So I'll describe the paper a bit here, but I would recommend to everyone to go back and follow this link to the DOI for the paper and actually read through it, because my top level description here doesn't get into all of the nitty-gritty details that I'm sure most of you would really like to know about. But the motivation behind putting this together, I guess primarily there's been this proliferation of data, and there's also been a gap in the literature describing this information and how a data set compares to other data sets. For many years, some of the only information available on comparing population products were written up in blogs that they weren't in the academic literature. So we're motivated to take a systematic approach to comparing the existing population grids and to put this out there for the user community to gain a better understanding of what the similarities and differences are, primarily for them to understand which one of these products would have the best use for their given application. So this term fitness for use really means that can a data set answer the type of question that I'm interested in. So, as I mentioned, the paper was written with a team of authors that many of them were on the production side, from organizations producing data sets. And there were also several folks from the user community. In POPGRID as a whole, very important for us to have an open dialogue with the user community so that we can address needs and that we can also educate folks so that they make the best decisions. Because, as Alex also showed in the SDGs, these population and settlement data, they're relevant to so many of the goals. We know that this information is relevant for a wide range of disciplines, even beyond those represented in the SDGs. So, that pretty much summarizes why we came together to write this paper. So I want to say a bit more about the concept of fitness for use. In academic literature, a 1998 paper talks about relative data quality, and goes on to say that for decision making, it's important to assess the appropriateness of any given data set for its intended purpose. So we found that there's a lot of uncertainty in the user community about this, and our goal really is to help folks make informed decisions by better understanding some of the underlying causes for similarities and differences between whichever data source you might select. So, in the context of this paper, we boiled it down into 3 characteristics that you would need to analyze in order to make some type of decision on whether a data set is fit for use. And those are, 1, what are the properties of the underlying input population data? As I was saying, is it from a census or a survey? What year was that survey taken? Those types of things. 2 is what modeling assumptions were behind a given product. And in the next slides, I'll go into some detail on the array of different modeling assumptions that are possible. And then 3, what ancillary data was used in creating this population estimation service? So, what other types of information were used in the model? So if we want to break down population data in terms of characteristics, some of them are fairly straightforward. Things like what projection is the data set in? What is the spatial resolution and the temporal resolution? What type of approach was taken to the data? To unpack that a little bit, there's certain information from a census that, was the census de jure or de facto? Was the census in place or on the day? Meaning, are we representing the places where people sleep at night, or are we representing the places where people are at any given time during the day? So it's important to understand what each of these data sources is trying to represent. Then, the modeling intensity, which I'll continue to go into, is extremely important, and the input variables I mentioned, like not only what is the population input, but what other ancillary data sets were used. On the bottom left here, it shows a group of 10 data sets that, in the context of this paper, were reviewed. You can also see here, just as a quick preview of the kinds of differences, on the right here in this graphic, all 6 of these data sets are looking at Greater Nairobi in Kenya, and they're all in the same classification scale, but visually you can just see how different they are. So let's get into depth on methodologies. So each of these data sets, they take a different methodological framework in terms of their data integration, and most importantly, how do they allocate population. There are a couple of different choices that could be made and when you want to disaggregate a population from a polygon into sub-polygon pixels. They're called aerial weighting at the simplest side of the spectrum. There's decimetric modeling, and there's a couple different flavors of that, whether it's binary or empirical. There's a statistical decimetric modeling approach, and as of late, we're seeing more and more folks take a hybrid approach where they use machine learning techniques and ensemble prediction to predict decimetric weights and then to further refine them. So what does aerial weighting mean? I mentioned this is on the side of the spectrum that is most minimally modeled. For example, we could look at the data set Gridded Population of the World, or GPW, as an aerially weighted data set. And GPW uses this method. It does not incorporate any ancillary data. So in doing so, it maintains fidelity to the input population information because there aren't other factors being taken into account. Aerial weighting means that population is uniformly distributed based only on land area within a given polygon. Therefore, it implies that the accuracy of any given pixel estimate is directly related to the size of the input census unit. For instance, in this graphic on the right, you see that within China, there's data in urban areas is much finer, and the data in the rural areas is much coarser. The same situation here in the United States. If you look at census tracts in New York City, there are many more of them, and they're much smaller than in a rural area like Kansas or Montana, where there are fewer of them. So this varies within a country, and it also varies dramatically between countries. So in an aerial weighting approach, since we're uniformly distributing population based on land area, the smaller the input unit, the higher the precision and accuracy of each one of those pixels that it gets disaggregated into. Now you can see how this could be problematic. This methodological framework slide it overviews several of the different approaches. I was just mentioning aerial weighting, which is represented on the upper left-hand corner here. As you can see, in an aerial weighting approach, Unit A starts out with an estimate for 54 people, and Unit B has an estimate for 36. And each one of the pixels within those units then gets the exact same estimate. So we know a priori that this isn't quite right. People don't live uniformly within a given area. However, there's usefulness in taking this minimally modeled approach because then population can stand alone and be incorporated into other models of land use, land cover change as a non-endogenous variable. Now, if we wanted to go up the ladder of complexity, if you look at the upper right-hand corner of this slide, there's a decimetric map based on binary weights. So in this binary weighting approach, we still have Unit A and Unit B. They start out with the same number of people as in the aerial weighting approach, but we've been able to identify the pixels within those units that are built up, that are settled, as well as pixels that are not settled. In a binary weighting decimetric approach, we then uniformly allocate population only into those pixels that we know contain settlement. So there are some data sets that will be described later that take this approach. And just to push it a little further, we also put 0 people in areas where we know that there is no built-up land. Now, this approach is nice, but you can see that it also has some limitations in that it's a yes or no decision, and we know in the real world there's more complexity. Just because an area is built up, for instance, it doesn't necessarily mean that it's settled. It could be a business district. It could be, some other place. So if you look at the bottom left-hand corner, there's a decimetric approach with empirically derived weights. So rather than just creating a binary mask, as we did in the last example, in the empirical decimetric approach, we assign weights to a number of different classes. It's easiest to think about if we consider land use classes. So we could say that we know that the land use class of built up contains the most amount of people. However, the grassland land use class also should contain some people. So in this example, we preferentially distribute people into the areas where we know there are settlements, and then we uniformly allocate the remainder to areas where there are different types of land cover. Finally, on the bottom right-hand side, there's a decimetric approach with statistically derived weights. So the benefit of this, we keep on gaining complexity in each one of these approaches. The benefit of the statistically derived weights is that we can include a wide array of ancillary variables. We aren't, locked down by only looking at land use and land cover classes. We can also consider things like distance to roads, or distance to water sources, or distance from coast, or many other types of things, in making better and more accurate predictions about where population should be placed. As I said on the previous slide, more and more people are taking hybrid approaches where they include decimetric statistically derived weights, and then they refine them using machine learning and cross-validation in order to get the most accurate and most precise weights possible. So again, I would advise you to go back and read through the paper. I understand these concepts are pretty thick, especially if you're just being introduced to them for the first time, but the paper does a great job of going through them in a systematic way. So we mentioned, as you use the decimetric approach to mapping, necessarily ancillary data comes into the mix. So it's important for users to understand the relationship of the population data and the ancillary data. Were the population data collected at the same times as the OpenStreetMap roads? Or for protected areas, when did these protected areas come into existence, and was it before or after we created a population estimate? You see here an example from the World Pop project where they've incorporated protected areas, OpenStreetMap roads, and elevation data in order to refine their population model. That project in particular, and also others that will be mentioned, they incorporate even more than that. They kind of, they look for what is the best available data sets, and then they use statistical analysis to measure what they call the loading of a given ancillary data set. How important is that data set for making a prediction about population? And you can use techniques like cross-validation to create statistical metrics for this. So one thing that anyone who's doing geographic analysis should be well aware of is that geographic data is not stationary. So that means the quality of geographic information varies by location. It's not equal quality everywhere. So when you start to incorporate ancillary data sets, you still have to deal with this stationarity problem. Maybe the OpenStreetMap roads in the US are really good, but maybe in a country like Costa Rica, they're not so good. So we need to be able to communicate with users what data was used where, and some type of understanding of what the quality of it could have been. At the end of the day, we want users to understand, are they dealing with different populations because the data sets used different input sources? Maybe one used census from the year 2000 and another used the census from the year 2005? Or are we dealing with different estimations because there's different underlying ancillary data involved? So when we review data aspects and their relative quality, we want to look at things like, do they aggregate well? How was mismatch between units handled? What is the scale and how current is the data? I mentioned this idea of, are we looking at nighttime or daytime population? That's like the semantics of what the population means. And we also want to know about these processing and model-related implications. Were there issues with integration? How was the integration accomplished? What is the overall modeling intensity? And is it possible that uncertainty in one of the ancillary data sets could have propagated itself through the model? So at the end of the day, for each user, they need to make a decision. Is this the right data for me? Is it fit for use or not? Fitness for use, as a theoretical concept, can be hard to grasp. So what we did in this paper is to conclude with some guiding questions to help users decide whether or not a data set is fit for their use. Those questions were, how important is the spatial refinement of the population grid? In other words, is high spatial resolution very important, or are you doing a regional analysis where high spatial resolution may not have as big of an impact on your end results? Does the analysis focus on urban populations? So if the answer is yes, you may want to choose to use a data set that has not already incorporated urban information into its allocation. Otherwise, you end up with this double counting, this endogeneity problem. So it's a question that we should each ask ourselves. What is the target population for the question at hand? Alex will get into use cases in a minute, but depending on which population we're looking at, the data set we select could differ. Is the population grid being used to model other outcomes? This goes back to what I was saying about urban populations. We need to know that the information we're using is decoupled from whatever it is we're studying. Is it important for us to analyze change over time? And if so, are we selecting a data set that represents a true time series, or are we selecting a data set where maybe a growth rate has been applied and we need to understand those modeling assumptions to see how to understand the change that's apparent? And you always want to ask, how have these data sets been used previously? So Alex, in a minute, will talk about some uses, but as time goes on, they're being used more and more. So ideally, a user should be able to do a literature review, find some other people who have had a similar purpose and used a certain data set for that. And then, in the most ideal world, they've also tracked the outcome. So I just wanted to throw this slide up as, another teaser for the types of differences that you'll see. You notice here that we're looking at South Africa across 4 different data sets here: GHS POP, GPW4, Landscan, and World Population Estimate from Esri. And visually, you can just see how the modeling has affected the distribution of population. We really want to get everyone away from this idea that getting the highest resolution data is the most important thing for their analysis. We need to educate users to the fact that depending on the type of analysis they're undertaking, different data sets offer strengths or weaknesses. So with that, I'll hand it back over to Alex.
Thank you very much, Kit. So I'm going to take you through a few use cases to give you a bit of a sample of what the implication is of some of these different data products for a given analysis. A few weeks ago, we were in Nigeria for a NASA-funded project called Human Planet, and we calculated the indicator 9.1.1 of the SDGs, which is the proportion of the world population who live within 2 kilometers of an all-season road. For one state, Nasarawa State, which is abutting Abuja, the capital of Nigeria. In this image, what you see is the blue areas are the 2-kilometer buffer of the road networks for Nasarawa State. We used 3 different population products, which I'll describe in more detail in a moment. One was a high-resolution settlement layer, GRID3, which is a custom data set produced for Nigeria under a Gates-funded project, and the GHS POP data set, each which has slightly different characteristics. What you see basically is that for the 3 different products, the percent of the state total population within 2 kilometers of a road does not vary terribly much. It's only between roughly 95% and 97% of the population. Given that the interest is primarily in populations near roads in rural areas, that percentage actually varies a bit more, from 28% up to 34%, depending on what product you use. And this would be a case where if you know that a population product already uses roads as one of its ancillary data layers to model a population distribution, you would not want to use that particular product. Additional examples of application areas include, for instance, this use of CDAC's gridded population of the world to assess the potential for hydropower and wind energy in different parts of the world, as well as potential demands for minerals. This is actually a product that we're now distributing at CDAC called the Development Potential Index. This is a conservation application. There are many types of conservation applications, but many of them involve an understanding of whether the impacts on conservation areas or protected areas in this case have actually changed over time. And so the figures at the top right show basically increases in many parts of the world between 1995 and 2010 based on different metrics, including human population, nightlife, and agricultural influences. These are changes in pressures on protected areas. And this is an example of a health-related study. As many of you know, the Southeast Asian region has been affected by periodic fires in peat bogs in Indonesia. And so this group looked at the impact of the smog generated by those peat fires from satellite imagery in combination with our population grids. If you're interested in looking at other applications of our population grids, you can go to the CDAC website, look at the Citations database, and if you select GPW version 4 or version 3 collections, you can find hundreds of different references and citations. The same is available through, for instance, the WorldPop website, where they have a very extensive list of applications. So I'm going to briefly describe some of the gridded population products that are available out there, and I wanted to just mention up front that all of this information is highly condensed, and expanded versions of this are available through the POPGRID website. So going back in time a bit, in 1995, CESN was involved with something called the Global Demography Workshop. We hosted it in 1994. We had colleagues from University of California, Santa Barbara, who were involved in something called a gridded population of the world, and this was the launch, essentially, of the gridding movement. And that paper came out in 1994. The data set that resulted, gridded population of the world version 1, was at a 5 arc-minute scale, which is roughly 8 to 10 kilometers at the equator, with only 19,000 census input units globally. So that you can see how coarse that population distribution was in the upper right-hand corner. That was followed by GPW versions 2 and 3. These used 2.5 arc-minute resolution, so double the resolution, although this all, of course, depends on the native census unit input resolution, which is vital. And so we went from 127,000 input units to 400,000 input units in GPW 4. For GPW version, 3, version 3 and version 4, we went to 12.5 million input units, although it must be said that about 10 million of those input units are in the United States alone, given the very high resolution block group input data that were used there. This was gridded at a 30 arcsecond resolution. It has a number of additional time steps, and we also have, in addition, sex and age distribution data. This is an image of the map of GPW version 4.11, the latest available version. We've been actually increasing incremental versions of the product as we improve the data. All of these maps are available on a map gallery that CISN or CDAC hosts on its website. In addition to just the population distribution, you can calculate things like the dependency ratio, which is the number of dependents per 100 working age persons. Areas in dark in Africa, for instance, have very young age distributions, so a lot of young dependents. In areas like Europe, there are more old age dependents, comparatively speaking, but there's still relatively high dependency ratios in those regions. You can also look at something like the sex ratio. In this case, blue areas have higher than anticipated male to female sex ratios, and the reddish areas have higher female to male ratios. So rural Russia shows a lot of elderly, and particularly elderly women, and the Amazon basin, by contrast, has a lot of men in particular, although the urban areas, which are hard to pick out here, tend to be dominated or have higher proportions of women. In 2005, CISN and CDAC developed something called the Global Rural Urban Mapping Project. This data set has largely been superseded by many other data-metric mapping products that have come subsequently. But this product was an open source product that basically took urban areas as defined by nighttime lights and buffered settlement points. So these are points, smaller settlements that had defined populations, and we set a circle around them based on the size of the population. And then we would reallocate the population from these larger census units into the urban areas, assuming that most of the population was found in those urban areas. So LandScan has been around for nearly as long as gridded population of the world has, and it was created in 1998 by Oak Ridge National Laboratory. It represents an ambient or 24-hour average population distribution. So it's neither nighttime nor daytime, but it's sort of a mix between the two. So you will find, generally speaking, that LandScan returns higher values in central business districts of many cities. It exploits a spatial data and imagery analysis technology in a multivariable asymmetric modeling approach, and it incorporates new spatial data and imagery into each of the distribution algorithms each year. So they release a new version each year. Like many of the other population grids, you are not really able to compare the population totals from one release to the next, or I should say the grid cell estimates from one release to the next, because they vary in their inputs. WorldPop was first released as AfriPop in 2009. At that time, it was based out of University of Florida. In 2012 and 2013, other regions were released, AsiaPop and AmeriPop. WorldPop has come about in 2015 and is led now by University of Southampton and includes CISN as a partner. Originally, the data set was focused on developing countries because it was really focused on especially health applications in the developing world, but has now expanded into a fully global 100-meter resolution data product. It uses machine learning regression trees to create population probability surfaces. One of the interesting characteristics of WorldPop is that you will see, if you look at it alongside gridded population of the world and some of the highly modeled population surfaces, that it often represents sort of an intermediate, because it still leaves populations behind in many rural areas and does not completely remove populations from areas that are not considered, quote unquote, built up areas. So GHS-POP is the Global Human Settlement Layer population. It's led by JRC at ISPRA in Italy and involves CISN and CDAC as co-partners. It distributes population based on satellite data, built up areas from the Global Human Settlement Layer. And those are based on Landsat time series data going all the way back to 1995, including 1990, 2000, and the more recent 2015. Kit will describe a bit more of the GHS built area in a moment, but basically this is an example of each grid cell being given a proportion built up area and then population allocated according to the proportion in each. Esri's World Population Estimate is a more recent entrant into the market, and they have annual releases since 2014. It's available in global image services and commercially available to ArcGIS users. So you can look at population counts, densities, likelihoods of settlement, and confidence scores using ArcGIS. Internet.org or Facebook was very interested in understanding the distribution of rural populations in order to better provide internet access to the world's last, I guess you could call it the last mile globally in terms of internet access. First began releasing data in 2017. It's the highest resolution input data of any of the different products out there. They use their server farms to using machine learning to process 0.5 meter digital globe data globally. The actual release product is not at 1.5 meters, but is at 30 meters. And we have close to 200 countries and territories that have been gridded thus far. It's a very useful data for rural population distributions. Finally, just to mention a data development effort that's under the Gates funding, and this is also with BIFID, the UK aid agency, and they are producing for a number of countries in Africa improved population grids. This is a capacity building project, so they're working directly with government stakeholders to develop the best available population data based on recent censuses in a number of countries: Nigeria, Mozambique, Zambia, and the DRC, the Republic of Congo, Democratic Republic of Congo. If you go onto the POPGRID website, you will find there are tables describing the inputs for each of the data layers I just mentioned, as well as a number of other regional and national products. So this table is a very useful summary to describe what went into these data products at a glance and what the resolution is and what the time slices are, etc. So we welcome you to look at that in more detail. With that, I'm going to pass the mic back over to Kit McManus.
All right. Thanks, Alex. So I'm going to go through these last slides in the demo a bit quickly because I realize we are running a bit long. So I want to introduce you to some of the settlement data projects. Alex mentioned GRUMP, the Grid Rural Urban Mapping Project. You know, how did GRUMP delineate urban extents? It did it on the basis of nighttime lights from the OLS DMSP sensor, and it represents settlements circa 1995. Although, you know, because of some of the blooming issues in that sensor, the settlements may actually be more representative of more modern times. So areas are defined as urban where contiguous lighted cells were present or they're approximated based on settlement points. So this is a night light space DMSP OLS product. You know, more recently, the NASA Goddard Space Flight Center has released through NASA CDAC this Global Human Settlement Extent Database, or HBase. This data is based on information from Landsat 2010 from the Global Land Survey, and it includes two important layers. One of them is the settlement mask, which is a binary mask of settled or non-settled areas, and then secondly, there's pixel-wise probability mask that allows for sophisticated uses. You know, maybe I want to select only settlements that have a probability greater than 90% for my analysis. This second layer allows us to, the user, to create those thresholds. The third one that has come up already is the global human settlement layer. You know, you heard Alex talk about GHS POP. You know, this is from the European Commission's Joint Research Center in Italy. So GHS POP uses first built-up estimates in this global human settlement layer as the binary decimmetric decision rules. And these built-up estimates are derived from Landsat for 1995, 1990, 2000, and 2015. And in the latest release, JRC also includes a built-up layer that's based on Sentinel-1 for the year 2015. These are all open data. And the important thing to mention is that because this is a true time series of remote sensing information, GHS POP represents a true time series of population along with that. It's one of the only products out there that has this true time series rather than growth rate applied models. Another data, or two data sets coming out of German Aerospace Center, DLR, are the global urban footprint and the world settlement footprint. So GUF, for the global urban footprint, represents data from 2012 that's based on radar information from TandemX. So this is interesting. Most of the other settlement layers we're looking at are based on optical data, but this is based on radar data. You know, unfortunately, as many of you probably know, the TandemX data has some license restrictions from the commercial company Airbus. So German DLR has undertaken this project again for 2015 and created the world settlement footprint. This is based on optical data like the other settlement layers we've seen from Landsat, but the thing that's really cool about it is that they partnered with folks at Google Earth Engine and literally processed every Landsat scene to create their probabilities of settlement over time. So I'd recommend checking this out. One thing I want to mention that is forthcoming from NASA CDAC is a data set by remote sensing expert Chris Small and others that fuses together the more recent Spears nighttime lights data with the older DMSP product in order to create a light change over time for the years 1992, 2002, and 2012. This data set will be coming in the first quarter of next year, if not sooner. It's called Delta Light or D-Light, and it allows us to look at light as, you know, a singular variable for predicting settlement extent and to extract that into 3 different time slices. So this is the list of settlement grids that are on the website. I mentioned most of them here, but this list will continue to grow as more and more data products come out. So with that, I wanted to quickly take you through a demonstration of our POPGRID intercomparison tool. So how do I get to it? You know, I'm just going to follow this link on the bottom of the screen. That's going to take me to this beta POPGRID website that Alex was mentioning. Just quickly to highlight on this website, if we go to the Find Data tab, there's a list of all these production partners, and if we follow any one of them, there's more information about the data products that they've contributed to the consortium. If I look under Explore Data in Data Documentation, you can see these tables that we've been referencing. Again, these are living documents that you can expect to grow over time. And then finally, under Explore Data, if I look at the POPGRID mapping tool, it launches first this 4-panel interactive viewer. And, you know, just to show the legend here in the viewer, we see these 4 data sets that are all linked to one another and all in the same classification. If I click around with my crosshair, I end up getting information back from each one of those data sets. So on a pixel by pixel basis, I can understand what's similar or different about each of the data. You can see that in some areas there's a lot of similarity, in other areas there's more differences. If I wanted to change out these layers, I have a control up here that allows me to switch GHS POP for Landscan, for instance. And then, you know, we can look at these same things. But so this is one level where we can make intercomparison. If I launch out a comparison view, so it takes me to a single map of the data set. And here I can get even more information. If I click on South Africa, I see some metadata from each of the 6 data sets that are included in this project, you know, in this map viewer. And it tells me things like the input feature count. You can see here that there's a big difference in the input feature count between the Esri's estimate and the others, but also the Esri's estimate is more recent than the others. The reason for this, Alex mentioned we've partnered with many of these other organizations. There's no need for all of us to recollect the census data, so we provide the Census 2020 round data as a base for many of these projects, so you can see that in terms of metadata, they're quite similar. So knowing that, then we can say if we want to do an intercomparison further, we can do that on the basis of modeling assumptions. We know that the input base is the same, so the models will be driving those differences. I just want to highlight in the table of contents here that you can switch between the different population data layers. And there's also some visualized metadata. You know, this is based on GPW4, but as you just saw, many of the data sets also reference GPW4. Of course, this is going a bit slower than usual. I imagine many of you are already here looking at this. So the last part of the demo I wanted to show is, you know, the best functionality out of this really is that we can look at aggregations of information. So if I look at Zambia here, and I draw this polygon, it'll take a second to come back, maybe even a second longer. 100 of you are on the site right now, but that's a good thing, right? You know, at the end of the day, it's going to show us in this aggregated area, how do the different data sets compare. So we get back a table and a chart that shows us, you know, that there's quite a lot of correspondence in this urbanized area, which you would expect because there's a similar baseline. However, if I do the same analysis in a rural area, I'll wait for that to come back. So I hope many of you are having fun with this viewer while we speak, and if not now, then later. You can see in the more rural areas, there's a higher intensity to the different correspondences, and this is related to that point we made about the size of the input unit impacting the results of the analysis. So we're running out of time here. I've gotten through everything in the demonstration. Let me switch back over to Alex and the slides and conclude.
Yeah, thanks, Kit. So this is just a little bit more information about how you can connect with us. First of all, we welcome you to go to the website. It's going through a redesign, as we mentioned, but you can look at the beta site that's available there, and we'll soon be in a production mode. We also encourage you to subscribe to the POPGRID discussion list. Simply send an email to popgrid+subscribe@googlegroups.com. If you have specific questions regarding POPGRID, please email season.info@season.columbia.edu. And with that, we'll hand the baton back over to Jennifer. Thank you, Jennifer.
All right. Thank you, everybody. At this point, we are running a little bit over, but we'll give these polling questions a couple of minutes or so. And I just wanted to note for everybody, we have quite a few questions. If we do not get to all these questions before 3:15, our speakers will be able to follow up offline with you individually. I will send them the Q&A log so that this can be your very thoughtful questions here. Really interesting questions, I might add, as well. So let's give these a couple minutes. Thanks, everybody. Okay, everybody. At this point, we're going to transition to the Q&A period. And if you think of something that you would like for us to pass along to our speakers, feel free to also enter that into the Q&A pod. So let me go directly. There was a question asked. Areas what the U.S. government calls block groups.
Well, enumeration areas is a generic term. So you have in the U.S. context blocks, block groups, census tracts, and then county and et cetera. So you go up from there. So yes, in the context of the U.S., an enumeration area would be a block group, but in other contexts or other parts of the world, they may call it by another term.
Okay, thank you, Kit. The next question is, you may have already mentioned this, but gridding loses administrative data, like what country people live in. Any fix for this?
Yeah, I mean, that's an interesting question. I think that what we put a lot of work into here at CDAC is to provide ancillary information about which pixel belongs to each country. You know, in the gridding process, when there's a pixel that is dissected, you know, it's on the border of two countries, the population in that pixel actually ends up being made up of people from, you know, more than one country or more than one administrative area. However, when you want to decide whether or not a pixel belongs to one country or another, you have to make some assumptions in doing that. So, you know, for the GPW data set, we distribute an ancillary layer called the National Identifier Grid. In that National Identifier Grid, we've decided that a pixel belongs to a country if it is predominantly in that country. So if more than 50% of a pixel on the Canadian-U.S. border is in Canada, then we assign that pixel to Canada. However, I do appreciate the question that, you know, having more information about where each of the estimates come from on a pixel by pixel level is important. At this point, the best that we can do is be clear about the assumptions we've made in making those assignments.
Okay, thank you, Kit. Our next question is, will there be projects on mapping poverty grids?
So poverty is definitely a high priority for CDAC. Some of you may be aware that we have a collection from 2005 of country level or city, it's basically small area estimates by country. As well as at that time we produced our first global grid of infant mortality rates along with another product called Global Child Malnutrition data set. We recently updated the infant mortality rate grid, so we have a 2015 version of that data set, which is available from the CDAC website. We are very interested in other poverty data and would welcome people to reach out to us at season.info@season.columbia.edu to share with us any other available data sources that you're aware of, because we do feel that this is a critical area. However, we do not have the resources at CDAC necessarily to produce all the data that might be valuable to the community at large.
Okay, thank you for that response, Alex. The next question is, were all of the gridded population data sets that you mentioned throughout the webinar available at CDAC or Season?
No, the answer to that question is no. The data are available in map services in the POPGRID viewer website. So Kit demonstrated that. Because they're available in map services, I assume they can be used for certain applications or APIs?
Yeah, that's right. So if you're building a web application, you would be able to reference those map services and to pull them in and to query them. However, you know, what we do in the POPGRID website is we make it very clear for the user where can you get the data. So the answer isn't always going to be NASA CDAC, although we are the host of many of the data sets. But when we're not the host, if you reference that POPGRID website, we do point directly to the portals where you can accomplish the downloads.
Okay, thank you. The next question is, I would like to know what tool is used to open the GPW data as GeoTIFF files downloaded from the CDAC website.
Okay, this is a very nitty-gritty question. I mean, I guess the catch-all answer would be to say a GIS tool. There are a number of different softwares out there, some of them commercial and some of them open source. For example, we partnered in the POPGRID Collaborative with a company called ESRI, which is the creator of ArcMap and ArcGIS Pro, which are commercial applications that could be used. You could also download an open source application like QGIS or GrassGIS, or there's another one called UDIG. Those are some of the more popular ones that you could open a GeoTIFF file in. So on the commercial side, Esri is probably the best bet, or maybe even Google Earth Engine, and who's also a partner with us on this work. Alex just reminded me that many of these data sets for people who aren't GIS users, they are available preloaded into Google Earth Engine. So Google Earth Engine, it allows you to do analysis within the Google ecosystem. So without downloading any software, you could sign into a browser and do some basic analysis on the data set. But QGIS is likely what I'd recommend if you don't want to spend money on a GIS software, but you want to be able to download something, install it, and open up a file.
Okay, thank you. So there was a comment earlier regarding the availability for the high-resolution settlement layer that, sadly, it's not global, it has limited countries. And so I wondered if one of you could speak to any future plans to further develop that particular data set.
Yes, the answer is yes, that there are plans and ongoing work to develop that data set further to cover more countries. Actually, even today, there's many more countries available through some of the links we provided in the slides and the Humanitarian Data Exchange than were previously available even a couple months ago. The priorities for that work is to focus on countries with limited internet connectivity. We mentioned that the primary funder of that work is internet.org, and their mission is to extend internet connectivity to underserved populations. So they prioritize those places. However, they're also very interested in data for good, so they are working on expanding the coverage I'm not sure the total number of countries, but quite a few.
Okay, thank you, Kit. The next question is, POPGRID concerns inhabitants. What about the dynamics of population, for example, seasonal, commuters available as ancillary?
Yeah, that's another great question. And I think that, when we talked about this continuum of modeling from the very simple approaches towards the more complex approaches, this is, even towards the extreme of being more complex. There certainly is interest in, mapping seasonal populations and an understanding that these are, population isn't stagnant, it moves around. And I think that there's a lot of ongoing work on that, but there's still a long way to go, to be honest with you. Alex?
I was just going to mention that we did not mention it explicitly in our presentation, but there are population projection grids as well. So we have grids that go out to 2100 based on work by Brian Jones and Brian O'Neill at the National Center for Atmospheric Research and CUNY Baruch. And so these data sets are available using different scenarios out to 2100, and it's a resource that's available out there, as well as settlement projections that we have available on our website.
And just one more point is that I think, all of us in this community, we're working more and more towards near real-time and real-time estimations of population. And there certainly is an understanding about this dynamic nature. But as I said, there's more work to do. So join us.
Okay, thank you. I want to be able to get to some questions from, okay. So the next question is, are there any plans to consider non-rectangular grids for population? Hex grids were discussed at the EFGS in Manchester this year.
Yeah, actually, yes. So when you say hex grids, the Open Geospatial Consortium, OGC, just last year approved an interoperability standard for these hex grids, or what they call the DGGS, Discrete Global Grid System. So at CDAC, we are working to create hex versions of GPW. I can't really comment on when they'll be available, but the answer is yes, we are working on it.
Okay, thank you. Just give me one moment as I scroll down. Okay. In many cases, census data, which serves as a source for gridded population data, does not include refugee populations. In such cases, there exists significant discrepancies. Is there an intention to tackle that issue?
So that's a really good question. I'm actually on the advisory group for NASA Human Planet Project, which is specifically focusing on mapping the missing millions. The lead on that is Jamin Van Den Hoek, who is based at Oregon State University, and he has developed some methodologies using remote sensing to identify and quantify the number of people living in refugee settlements around the world. So yes, there's a great interest in that. It goes along with the question on temporal resolution and getting more seasonality. Truth is that humans are a bit messy and they don't stay in one place. So pretending that people have stayed in the same place as, say, the decadal census in the US in 2010 obviously is a bit of a misconstruction of how we understand population, and we really do need to introduce more dynamism in the products that we're developing.
Yeah, just one more point on that. In the GPW data set, in the documentation of the GPW data set, we went to great lengths to capture this type of information when the census reported that there were these types of errors. So, it is something that you could reach out to season.info at season.columbiauniversity.edu about, and we very likely, have information for specific use cases.
All right. The next question, the final question is, I need HBase and GIMS for the entire globe. Will there be a more efficient mechanism for downloading it all? The current interface doesn't allow for a global download. Even something like an FTP site would help. Alternatively, could I send a hard drive to be loaded?
Yeah, that's an interesting question. The API does allow for programmatic downloads of that data set. That's something that I work directly on. So, my email is going to be available through this. If you, personally want to reach out to me, we can talk about how best to obtain that data. But, it follows a pattern with the URLs, so programmatically it should be pretty straightforward to obtain.
Okay, thank you, Kit. So at this point, what we will do is we will leave the virtual meeting space open for an additional 10 minutes or so. So if you think of a question or you have additional commentary, please type that into the Q&A pod. I'd like to thank our speakers and all of you for joining us today. And I also wanted to draw your attention to the fact that today's presentation file is available for download in the lower right-hand corner of your screen. It's a persistent feature, so if you listen to this webinar, once we post the recording link through the direct link, you will be able to download the presentation file by clicking on it, and then you should be prompted with an option to download the file. And you can do that also once the recording links have been posted. So again, thanks everybody for your participation. At this point, we will log off from the audio component and leave the virtual meeting space open. And thank you to Alex, and thank you also to Kit.
Thank you very much, and thanks everyone for taking the time today.
All right, with that, thank you, and we will hang up from today's webinar. Goodbye, everybody.